Hello, and in this video we're going to use some of our past skills from logarithmic properties to help us solve exponential equations. So in the past we did exponential equations where we made the bases be the same. So we had a problem like this and we rewrote it. We looked over here on our calculator, said that 2 to the 7th power is 128. So we went back over here and wrote down that 2 to the 5x, oops, it's not writing, 2 to the 5x is equal to 2 to the 7th power, because that's what 128 is. And then since we had the same bases, we then can write 5x, the exponents have to be the same. 5x equals 7, x equals 7 divided by 5, or 1.4 if we wanted a decimal for that. If we want a mixed number, it'd be 1 2/5. All right, so that's what we did solving exponential equations in the past. We took the bases and made them the same. Well, there are going to be problems where that's not going to be able to happen. So we're going to look at a couple examples and use our properties to help us do that. So in this first one, we're going to go back to the moon problem where we found out it took like 39 folds, I believe, to get to the moon on the paper. And we're going to do that problem using our properties of logarithms. And in this case, we're going to remember that the paper folding one has a function of 2 to the x. So this was our folding paper function, so that every time we folded a paper it doubled. And this was the distance to the moon. So if we wrote the equation from that, it would be 2 to the x equals 3.8 times 10 to the 11th power. Now in solving this problem, what we would do is we would use the property of logarithms. We would want to solve for this x in the exponent. We're going to use the multiplication, or the property that says log base a of m to the r power is going to be equal to log base a, or r times log base a of m. So we can move the power down in front. So we're going to want to do that in this problem. So what we would do here is we would evaluate both the sides of this with a logarithm. So we would take the log of both sides of this equation. And we're going to use a logarithm we can use on our calculator. And in here we would write 2 to the x and 3.8 times 10 to the 11th power. Now, this is some number that we can evaluate on our calculator. We can take the log of this value on our calculator. But this side over here now, we can use the properties of logarithms to simplify it. We can move this into the front of this logarithm. So we can write it x times log of 2 equals log of 3.8 times 10 to the 11th power. So in solving this equation, all we would need to do is divide both sides by log of 2. Log of 2 is also a decimal found in your calculator. And then once we've done that, that gives us the x value that we're looking for. So we now know what x is. We now know x equals log 3.8 times 10 to the 11th power divided by the log of 2. Now to evaluate that, we just use our calculator. We'd put in we're hoping that we can get close to 39 here. This is what we got before. We just do log of 3.8 times 10 to the power of 11 divided by log 2. So there we go, 38 point, so we got here 38.467. So and in folds, that would be 39 folds. If we had 38, we'd have less than our value. 39 would be our answer. So that verifies what we did before, but we used logarithms to solve it. Now, my second example was in that same section where we did population. Population of a city was growing at a rate of 5% a year, and the initial population of the city was 20,000. Our equation of our population was P equals 20,000 times 1.05 for the growth rate to the x power. So 5%, this was our 5% growth, this was our initial amount. So those two values always go there. This is my equation, and if I answer the question, when is it 10,000 or 100,000, when is it 100,000, we would then write an equation with 100,000 in it. 100,000 equals 20,000, 1.05 to the x power. So this would be my equation that I would want to solve. And we're going to use logarithms again to try to move this x down in front of that value. So first step here, though, would be to isolate the exponential function. So we're going to divide both sides by 20,000. So we're going to divide by 20,000 on this side. We're going to divide this by 20,000 also. Okay, so we're going to get 1.05 to the x power equals, we're going to reduce this out. Basically, we're going to end up with 5 here. 2 into 10. So now we're going to do what we did up above, and we're going to apply our logarithm. So we're going to take the log of both sides. So we're going to do log of 5 equals log of 1.05 to the x power. Now our rule says, our exponent rule says, now we can move this, since we have a logarithm here, we can move this in front and write x times a log of 1.05. Now the 1.05 log and the log of 5 are both whole numbers. So we can now divide those whole numbers together. We can put them all on one side together and divide each side here by log of 1.05 to reduce this side just down to x, and this side over here will be just two logarithms that are divided, and we can figure that out in our calculator. So x is going to be that value. Log of 5 divided by log of 1.05. And we're using our calculator here to figure that out. Log of 5 divided by log 1.05, and that's approximately 33. So x is going to be about 33. We round. Even if we round to 3 decimal, well, 3 decimal places, it's going to be 32.997. If we go to 3 decimal places. It's really close to 33 though. All right, my last example here on this part, we're going to solve this exponential function. So first of all, we need to isolate the base. So in all of these that we've been doing, we've been isolating the base with the exponent. So we got the 1.05 to the x by itself. We've gotten 2 to the x by itself in the first example. Same thing's going to happen in my third example. I want to get e to the x by itself. So my first step here would be to subtract 7 from both sides. So we're going to get 4e to the x equals 24. And then we want to divide by 4 to get e to the x by itself. We would then get e to the x equals 6. Now on this type of problem, rather than using log base 10, since this is base e, I would use the other logarithm. We can use either logarithm when we apply this, but since the logarithm, the natural logarithm, is the inverse of e to the x. When we take the natural logarithm, we will just get these two things to undo each other, and we will get x equals ln of 6. So we can easily, we won't have to do a division here, because we can have this undo each other in this process if we use ln instead of log. Now we can do this with log, the common logarithm too. We're just going to have to divide in the end. So this is my answer, natural log of 6, which in this case is about 1.792, approximately 1.792 to 3 decimal places. Okay, I do have one more example here, and I think that I wanted to show you this example because it has powers on both sides, exponents on both sides, and it's a little bit more complicated algebraically to solve. So we still go through the process. We take the log of both sides, but in this case we're going to end up with bringing down both powers and solving that. So in this case we're going to have 2x plus 1 in front of this logarithm, and over here we're going to have 5x in front of this logarithm. So we're going to have to put all the x values together on one side. We happen to have, this just makes it more complex in solving this problem. It's just that we have two x values instead of one, and we're going to have to put them on the same side together and factor. So I'm going to leave this one alone. I'm going to do distributive property here on this side, so I get 2x log 4 plus log 4, because that's what 1 times log 4 is. Now I'm going to put this x value and this x value on the same side together, 5x log 3 minus 2x log 4. When we subtract, we subtract this 2x log 4 from both sides, and we'll get this property. Now what's going to happen here is we have to use we just have to think about this as a multiplication problem. So what we're going to need to do is factor in order to get the x by itself. We factor the x out of this side. So if we take the x out of this term, we're going to have 5 log 3 as that term that's left over after we factor out the x. And then if we factor the x out of this, we're going to have 2 log 4. So now we can divide by this whole amount. This is just a numerical value. We could divide by this, and that will give us x. So x is going to be log 4 divided by this whole amount, 5 log 3 minus 2 log 4. So you can use your calculator and approximate what that is. Let's see if I was typing it in. Let's see if I did that, what it would be. Log 4 divided by parentheses 5 times the log of 3 minus 2 times log of 4. We need two parentheses down there to get the whole parentheses. So this, I say, is about 0.510 if we round up. All right, and that's it. That's using your logarithmic properties to help us solve exponential equations. All right, good luck.